Hello everyone, my name is Yash Chopra. I'm a computer science and engineering student at UMass Amherst, and this is my Quantum Hacks project, Problem Forge. The idea starts with a simple question. What if getting the answer is not the hardest part, but understanding the problem is? Problem Forge helps you understand, question, reframe, and test a problem before committing to a solution. I am now going to show you the site in live action. For this demo, I am using Problem Forge's guided example so you can see the complete reasoning journey consistently from beginning to end. I will now click on Try the guided example. Over here, we start with the solution already in mind. In this case, it is an AI app to help students manage overwhelming coursework. Problem Forge keeps that idea, but asks us to examine the problem before committing to it. Instead of immediately recommending the app, Problem Forge separates competing explanations. Maybe the coursework volume is too high, maybe students need better time management strategies, or maybe expectations and deadlines are unclear. And critically, it does not pretend these are facts. The evidence status stays visible. For each explanation, I can see why it matters and what evidence could actually check it. The full reasoning also exposes who is involved, the constraints, what we do not know, what is being assumed, and what evidence we actually have. Now, Problem Forge challenges its own reasoning. The key assumption is that student overload is primarily caused by poor individual planning. If that is true, the AI study planner stays first. If it is false, cross-course deadline coordination becomes the leader. That makes this assumption especially valuable to investigate before building anything. At this point, Problem Forge reframes the question. Instead of assuming students need a better tool, it asks whether systematic causes like workload, unclear expectations, or inadequate support are driving the problem. And here is a key moment. These solutions have not changed. Our understanding of the problem has. The AI study planner drops from first to fourth, while cross-course deadline coordination moves from third to first. The model proposes qualitative judgments. Deterministic code computes the scores and rankings. These are directions to test, not probabilities or verdicts. This is the idea in one picture. Challenge one assumption, recompute the same options, and see whether the direction changes. I will now go to step 5, and I will click on the direction with the highest ranking. On this step, Problem Forge still does not tell me to implement the new leader. It proposes the smallest useful test first. Here, that means collecting assignment and exam dates from one program and checking whether high-stakes deadlines really cluster in the same weeks. The success threshold is set before reviewing the results, so success cannot be redefined after seeing the data. I will now go to the 6th and final step. The final action plan says exactly what to do next. Do not commit to the AI study planner yet. Run the small test first and use the evidence to decide what happens next. Cross-course deadline coordination is the highest ranked direction to test, but Problem Forge clearly says it is not yet verified. Even after all 6 steps are complete, it makes an important distinction. Process complete is not evidence confirmed. Nothing has been proven until the test is actually run. So Problem Forge turns one messy problem into a 6-step reasoning journey. Describe, understand, question, reframe, test, and plan. Underneath it is one rule. The model proposes, and the engine disposes. AI generates structured judgments, while deterministic code owns the scores, rankings, and hinge logic. Anyone can ask AI for a solution. Problem Forge is built for the step before that, making sure you are solving the right problem before you build the wrong solution. Thank you.